Hi, and welcome back to this introduction to dApp development. In the previous episode, we talked about what makes a dApp, some advantages and disadvantages of dApps in comparison to regular applications, and some reasons to build your dApps on Tezos. In this episode, we're going to look at the architecture of a dApp and get an overview of all of the different component parts, as well as the libraries and SDKs that we're going to need to integrate these different component parts with our dApp. So let's start with smart contracts. As we talked about in the previous episode, dApps don't have a backend, or at least the code of the backend runs on the blockchain and is called a smart contract. So smart contracts, as the slide says, are programs or pieces of code that run on the blockchain. And the two main features of smart contracts are that they have entry points and storage. So if you were to think of a smart contract a little bit like a class in Java or a similar object-oriented language, the entry points would be like the Java class's public static functions, and the storage would be like the Java class's fields. And it's kind of as simple as that. If you keep those concepts in your mind when we actually dive into smart contracts, then hopefully it'll make a lot more sense. You can also see in the bottom right of the slides here, the kind of icon that I have here, and that icon is representing smart contracts. So just keep that in your mind in the subsequent slides when you see these four things that look a little bit like they could be code or pieces of code. That is meant to represent smart contracts. A final note as well, and this is something that I think is quite useful to keep in mind when you're getting your head around the concept of a smart contract, is that tokens on a blockchain, for example, NFTs, that you may have heard of before, it's a type of token, a non-fungible token. NFTs are essentially implemented as smart contracts that conform to a certain standard. So this is just to say that NFTs aren't necessarily something that is intrinsic to a blockchain itself. NFTs are just a concept that exists within a certain smart contract. You can see in the top right of the slide here that I've written a little bit of pseudocode to actually demonstrate what an NFT smart contract would look like. You don't need to worry about the details at all. Some people learn in a way that they find it much easier when they're reading code or pseudocode. So if this is useful to you, do take a look. To be clear, it's not totally accurate. It has, I'm sure, lots of security flaws in it. But this is actually the basis of a smart contract that would enable you to mint and transfer NFTs. Okay, up next, blockchain nodes, or as they're more technically known, RPC nodes. So, as you may know, a blockchain node is a machine that runs a copy of the current state of the blockchain. And all of the nodes in a blockchain stay synchronized with each other using consensus algorithms and broadcasting. In the context of a dApp, you can think of a blockchain node a little bit like the backend / database for your dApp. So the backend / database of a regular app, what does it allow you to do? The main things it allows you to do are read the state of your app from the database and also write updates to the state of your app. So in dApp world or in blockchain world, that means that the node needs to allow us to read the state of the blockchain, or at least the part of the blockchain that's relevant to our dApp, which is the smart contract storage and maybe some other parts of the blockchain. And also it needs us to submit operations to the blockchain to change this state. So in this diagram on the right-hand side here, this is the diagram / icon that we're going to use throughout this episode specifically and a little bit throughout this whole course to represent an RPC node. It has quite a lot going on. You don't need to worry too much about the details, but hopefully this visual representation of an RPC node might help you understand what's actually going on. So we'll briefly go through this step by step. So at the top, you can see some horizontal lines here, These are representing a queue of operations that have been submitted to this node. And then one of those operations, one at a time, will be processed by one of the smart contracts that we saw in the earlier episode. And then the output of the operation being run through the smart contract, the output of it will be added to the most recent block in the blockchain. So this part at the bottom is the blockchain, the bit in the middle, the smart contracts, and the bit at the top, as I said, is the queue of operations waiting to be submitted. So hopefully anytime you see this icon, you'll think RPC node or blockchain node, and it'll give you a little reminder of what's actually going on. We have operations coming in, this is to reiterate, some operations coming in, they get processed by the smart contracts and they update the state of the node. Sorry, the state of the blockchain. So returning to the context of our dApp, if we want to read our backend, then we can read this blockchain at the bottom. And if we want to write to it, then we have to insert an operation here at the top and wait for the RPC node to process it and update the blockchain accordingly. The final thing to say on this topic is that within the context of Tezos, you're going to hear the term Octez a few times, and Octez is just the name of the Tezos RPC node software. So if you're running Octez on your computer or on a server in the cloud, you are turning your computer or your server into the cloud into a Tezos blockchain node or into a Tezos RPC node. The next topic that we're going to talk about is file storage. So for many apps that you may have written before, you often need some form of file storage. Sometimes that's file storage on the web server itself for your app, or maybe you're using some form of cloud storage like AWS S3 or something like that. And for our dApps, we are also going to want file storage. But we want that file storage to be decentralized for exactly the same reasons that we want our app to be a dApp, i.e. our app to be decentralized. So the blockchain itself, Tezos, could be used for this storage. And in fact, it is actually used for some storage. The Tezos blockchain is used for to store the code of the smart contracts. And the storage within the storage associated with the smart contracts is also stored on the blockchain. And the blockchain ledger itself, the list of all of the completed operations, is also stored on the blockchain. So that's three things that are stored on the blockchain. So we might be thinking, okay, well, why don't we also store the files for our dApp on the blockchain, be they images, videos, JSON configuration files, whatever. But that would get really, really expensive if we did that. Storage on blockchains is very expensive. So that's totally, it's fine and manageable if you're just wanting to store a little bit of code or a little bit of state. But if you're wanting to store some huge image or some video, it would quickly get infeasibly expensive. So how do we get around this? There are... What dApps do in this situation is they use a separate distributed system for file storage. And because it's distributed, it's sometimes referred to as D-storage. So a little lowercase d before the word storage. And an example of a D-storage solution, a decentralized storage solution, is IPFS. It's the best known and the most widely used. So IPFS stands for Interplanetary File System. It's a pretty wacky, awesome name, but don't get overawed by the fact that it has the word interplanetary in it. It's essentially a decentralized peer-to-peer network, similar to a blockchain, but one that is optimized for file storage. And because it's decentralized, it shares some of the concepts and advantages and disadvantages of dApps in general. Finally, in the bottom right-hand corner, again, we've got another icon, and when you see that icon in subsequent slides, that is the one that represents our distributed storage. Okay, we're making some good progress. Only two main architectural concepts to go. First up, indexes. So on slide 3, which was the slide about RPC nodes or blockchain nodes, we discussed how the back end of a dApp is essentially the blockchain, or an RPC node of the blockchain. And we discussed how the role that the RPC node of the blockchain, the role of it within our dApp was to allow us to read data from the blockchain and also write data from the blockchain. Now, when it comes to reading data from the blockchain, it's not actually as simple as you might think. So, unlike a regular backend or database, a blockchain node doesn't have any APIs or query language to make searching and aggregating the blockchain state really quick and efficient. So this is where indexers come into play. So essentially, under the hood, as this diagram is hopefully showing you, the indexer, which is on the right, its role is to read the blockchain, the raw blockchain state, which is not queryable in any kind of efficient way. It reads it and it processes it, and then it stores the data from the blockchain in SQL tables that themselves are much easier and more efficient to read. So it's just to kind of reiterate that. On the slides here, you can see this representation of the blockchain itself, which is as unqueryable and unreadable as just maybe a plain text file. It ingests it and transforms that unqueryable data into SQL tables that are designed to be efficient and easy to read. And then it exposes an API on top of that database so that we can query the API and find out all sorts of efficiently find all sorts of information about the blockchain without having to step through the raw data itself, which would take minutes, hours, even days, for particularly big blockchains. So an example of an indexer in the Tezos ecosystem is called tzkt, and that's the indexer that we'll be using throughout this course. But we'll revisit all of these concepts in subsequent episodes. So if you're struggling to keep up with all of these concepts, please rest assured that we'll revisit them in more detail in the subsequent episodes. And on to our final architectural concept, and that is a wallet. So wallets are applications that allow users to manage a Tezos account and interact with the blockchain using that account. Some wallets allow users to manage multiple accounts in a single wallet, but during this course, we're just going to assume that our wallet is only managing one Tezos account. So your next question might be, what is a Tezos account? At a low level, a Tezos account is simply two strings, a private key and an associated Tezos address. If you want to use an analogy of maybe a bank account, then you can think of these two strings like this. So the two strings, just to reiterate, were a private key and a Tezos address. You can think of the private key a little bit like your PIN number or your signature. It's something that allows you to authorize transactions. And you can think of the Tezos address a little bit like your bank account number that you would give to a friend or to someone if they were going to pay you money. So the Tezos address is something that's public and you're perfectly fine giving it to other people. In fact, you give it to them when you want them to send you stuff. But the private key is something that you keep private because you use it to authorize transactions. So that's all a Tezos account is. But to actually manage your Tezos account, you could either use command line tools or you can use wallets, which are applications that are designed to make it easy, much easier than command line tools, much more visual, much more intuitive, and much safer in many situations as well. So that's what wallets are. So if we want users to be able to use their wallet to interact with our dApp, then obviously we need to make sure that we're integrating with all of these different wallet providers in our dApp. And we'll discuss, obviously, how to do that in subsequent episodes where we focus on wallets and wallet integration in dApps. The final thing to note, and you'll see that this point highlighted here, and you may have heard it many times before, but if you haven't, it's definitely worth it repeating. You should never, ever share the seed phrase of your wallet or the private key of your account with anyone. Think of it like the PIN number to your bank account. You don't want to share it with anyone. The only thing that should ever be shared is the Tezos address. So be very, very careful. And then just finally, this diagram at the bottom, hopefully this makes sense within the context of what I've said before, but you can see how here we have a dApp submitting an operation to a RPC node, which is the horizontal arrow here. This is it submitting the operation. But first of all, it needs that operation to be verified, validated, signed is the technical term in many situations, by a wallet, and that's what this little arrow represents. So the dApp submits the operation to the wallet signs the operation, and then it goes to the RPC node. Okay, so we have now had an overview of all of the different architectural concepts that we're going to need in this dApps course to build our dApp. I've put all of these here on a diagram to show the flow of data that you would get in a dApp, and also it's annotated with which episode we're going to tackle that part of the overall dApp flow. So let's walk through an example here where, let's say in our imaginary dApp, let's say it's a Web3 game, and we want to post an operation to the blockchain to, let's say, update the position of our character. So first of all, the user says that they want their character to move from X to Y. So the first thing that happens is that the user signs this operation using their wallet. So this is a concept that we're going to cover in episode 4. And then the operation goes to an RPC node. We're actually going to cover that in episode 8. And then the operation goes into the queue, called the mempool. And then that operation is executed by a smart contract, which is, remember, our backend code. We're thinking of it as our backend code. We're covering smart contracts in episode 6. And then when the smart contract has done its processing, the output of that operation is written to the blockchain. Then an indexer will pick up the blockchain updates and will process them. It will update its SQL tables, and that the output of that operation that we submitted will now be available through the indexer. So that means that our dApp can then read that new information from the indexer, and that is a concept that we're going to cover in episode 5. And then the final part of the puzzle is that our dApp might use some kind of file storage. Maybe it has some images, some videos, or something like that, some configuration files, and it will read those through distributed file storage, for example, IPFS, and we're going to cover that in episode 7. So I'm now going to annotate these slides with the different SDKs, libraries, services that we'll be using specifically for these components. So here they are here. The dApp itself, we're using Next.js. For our wallet integration, we're using something called the Beacon SDK. For submitting our operations to the node, we're using something called the Taquito SDK. Our smart contracts will be written in SmartPy. The indexer that we'll be using is called TZKT. And finally, for our distributed storage, we'll be using IPFS via an SDK called Pinata. So this is hopefully going to be a useful slide for you to refer back to when you're trying to understand how these different concepts tie together. And when we visit the different SDKs, you'll be able to look back at this slide and go, okay, this SDK is doing this part of the puzzle. So we're just going to have a couple more slides during this episode, just doing a really brief overview of some of these SDKs, and then that'll be the end of the episode. We're going to look at is the Beacon SDK, and if you can remember from the previous diagram, that's the one that's going to allow us to integrate with the different wallet providers. So as the slide says, the Beacon SDK is a single SDK for Tezos dApp developers to seamlessly connect to multiple different wallet providers. It means that we don't need to integrate with each of the wallet providers one by one. We can just use this single SDK and it'll give us access, or it'll allow our users who want to use any wallet that they want to, they can all integrate with our dApp because we've just integrated with the single Beacon SDK. And that's what the bullet points are kind of saying. All Tezos wallets implement the beacon standard, and that means that they can interact with any dApps that use the beacon SDK. The standard is available in TypeScript, and the beacon SDK is very battle tested, so we can definitely trust that it's going to do a great job. Next up's Taquito, and as you may remember from the slide where we had the architectural overview, Taquito is the SDK that we're going to use when we want to submit operations to the blockchain, to a specific blockchain node. It's written in TypeScript. It's really straightforward, and the documentation is really clean and helpful, and it is the most popular library for doing this in the Tezos ecosystem. And finally, Pinata. Pinata is the SDK that we'll be using for uploading and pinning files to our distributed file storage network, which is called IPFS. So one little note on what pinning is. Pinning ensures that your documents don't get forgotten by the distributed storage network. This is a concept that we'll revisit more in the episode where we talk about distributed storage. But if in the meantime you hear this concept of pinning, it's just something that needs to be done to make sure the network doesn't forget your files. IPFS also offers various optional features, such as dedicated gateways that allow really fast retrieval of your assets on IPFS, and also sort and search functionality that makes organizing your IPFS assets really easy. And that's pretty much it. So thank you so much for your time. I know this was a bit of a long episode, but now we've got a really good overview of the main architectural concepts, and it should allow us to get cracking with actually creating our dApp in episode 3. So see you then.